Large language models have taken over. They're reshaping how we build products, work, and interact with technology. From content generation and coding to customer support, LLMs are unlocking immense new capabilities. And as seen weekly in the news, they're not slowing down. But behind the excitement is a hidden cost. Today we're diving into that cost, specifically the economics of deploying models and why model compression is a requirement. Let's start with the obvious. Models are getting bigger fast. The Llama 4 series now establishing a new trend of foundation mixture of expert models, where they release 109 billion, 400 billion, and soon to be 2 trillion total parameter models. Meanwhile, accelerators haven't kept pace. Memory per GPU has increased by barely double over the past 5 years, with the latest B200 GPUs reaching a maximum of 192 gigabytes. Instead, the focus has primarily been on networking more and more accelerators together, which only further increases the cost through more GPU purchases, along with dedicated and expensive high bandwidth networking, with the latest at 1.8 terabytes per second transfer speed. Considering only fitting a model's parameters on those accelerators, a 109 billion parameter model requires 3 H100s. 400 billion, you're looking at a minimum of 10 80 gigabyte GPUs. And that's not counting the memory for active requests. For medium lengths, we're looking at 2 gigabytes per request, and for long context and especially the latest reasoning models, it's an order of magnitude increase to 25 gigabytes. What this means in the end is that for realistic deployments that can handle a reasonable number of requests at once, we need a full 8 by 80 gigabyte GPU server for 109 billion and 2 8 by 80 gig GPU servers for the 400 billion. On the lower end, even a 70 billion model can require up to 4 80 gigabyte GPUs. Only when we get down to the 8 billion parameter class of models are we able to reliably fit onto a single GPU. But that's usually at the expense of accuracy. The final result, for any company deploying their own LLMs, whether that's to ensure data privacy and security, to guarantee the lifetime support of a model they're using, to reduce overall costs, or a myriad of other reasons, it becomes an expensive proposition to deploy and maintain, generally hindering the potential savings they had planned. If companies aren't careful, thoughtful, and well-planned for their goals and deployments, startups can easily run through tens of thousands of dollars a month to deploy a single use case. Enterprises, that's hundreds of thousands of dollars. Okay, that's the problem. Now let's talk about solutions, and the good news is we don't have to play this game at full price. Model compression is the answer. Specifically, compression techniques work by targeting one or all of 3 potential bottlenecks for inference: the compute bandwidth requirements, the memory bandwidth requirements, and the total memory footprint. The best techniques accomplish this without compromising the model's accuracy. And let's run through a quick breakdown. First, quantization leverages the fact that LLM training is extremely noisy, resulting in redundancies throughout the entire network at the baseline precision. We can exploit this by reducing the number of bits required to represent various components of the model, and therefore the memory and compute bandwidth to run through. This includes activations, waits, the KV cache, and even the attention operations. In general, this alone enables 2 to 4x faster or cheaper deployments. And extending this to training, we can use QLoRa and other techniques, making fine-tuning both cheaper and faster. Second, pruning, where we remove connections from the network entirely. This relies on redundancies built into the training process in a large search space where we converge on a much smaller optimization space after exploring through training the portion that actually matters. We can exploit this by reducing the number of parameters we need to store and skipping compute for those removed connections. With these techniques, a 50% sparse model is 1.5 to 2 times faster or cheaper for inference. Next, let's talk through knowledge and data distillation, which allows us to shrink the problem even further. In knowledge distillation, we're training a much smaller model to match the behavior of the larger one, learning from the full distribution of the outputs rather than just a single next token for the correct answer. In data distillation, we generate high-quality, enriched synthetic data sets from that larger model that enable smaller models to learn faster and more effectively. Both methods unlock the ability to deploy models that are up to 10 times smaller for specific tasks, while still maintaining accuracy. Fine-tuning and iteration times also drop significantly, allowing teams to move faster while spending less. Finally, speculative decoding takes a different approach entirely. where rather than reducing the model, we're actually extending it to improve performance. Specifically, it adds a smaller, faster speculator model that predicts multiple tokens ahead in the sequence. The larger, more accurate model then steps in only to verify those predictions. As long as we're running less compute-intensive scenarios, then verifying adds very little overhead, and we shift the memory bandwidth limited portions to a smaller model. With these techniques, we can cut inference latency anywhere from 2 to 4x. Finally, combining the techniques enables compounding gains, where a 10x smaller distilled model can be quantized, enabling a further 3x performant gains on top of that. And yet today, over half of vLLM deployments are still running uncompressed models. And that's a lot of wasted compute and money. So let's dive into some examples to approximate just how much these deployments might cost. Specifically, let's look at two very common use cases: online retrieval-augmented generation, or RAG for short, and offline summarization. We'll look at deploying these on H100 GPU systems where we're at $2.40 per hour per GPU. If deploying on an A100 setup, then you can estimate those numbers by roughly 60% of the costs. For online RAG, we define this as an augmented question answering or support pathway where an LLM uses a knowledge base of previously collected data to answer real-time queries from both internal or external users, hence the online designation. These scenarios have constraints around the latency for each request that the deployment needs to satisfy while maximizing the total number of requests that it can handle to minimize those costs. Additionally, RAG scenarios generally are prompt heavy, with up to 10,000 tokens, roughly equivalent to 3x the number of words, and their prompts and a few hundred tokens in response. A small startup deploying an online RAG use case that needs to handle roughly 10,000 requests per day will require about $15,000 per month for the 109 billion parameter model and $30,000 per month for the 400 billion model. A large enterprise, potentially handling 1 million requests per day or more, will need significantly more servers and scaling to that level, meaning roughly $200,000 per month for the 109 billion model and $400,000 per month for the 400 billion model. But with compression, we can significantly reduce those numbers by serving more requests through the same deployment and reducing the number of GPUs each deployment requires. Using just quantization, we can reduce these numbers by 1/3 to 1/2, resulting in $5,000 per month on the low end and $130,000 on the high end. Further adding in data or knowledge distillation for the dedicated use case enables us to swap in a fine-tuned 8 billion size model with around the same accuracy as the generally trained larger models. This further reduces our cost by roughly 8x, where we can now fit on a single 80 gig GPU, and quantization improves this performance even further. This results in $1,000 per month or less on the low end and $30,000 on the higher end. Adding in even more optimization, such as speculative decoding, only further reduces the numbers. For offline summarization, we define this as a standard review or product summarization use case, enabling concise and informative summary for customers of previously submitted content such as reviews. For these types of use cases, we generally don't need to update a summary immediately. Instead, we can update at some later point, allowing us to batch multiple requests together and schedule them for overall cheaper inference. This is the offline part of the scenario. Similar to RAG scenarios, these deployments are prompt heavy, with up to a few thousand tokens in their prompts and a few hundred tokens in response. In this case, our total at the higher end is reduced by roughly 30% due to removing the restrictions on request latency, but we're still looking at $150,000 per month at the highest end. The lowest end remains the same, unfortunately, since we need the full server size to run the requests. We achieve similar scale, though, utilizing distilled models and quantization, with quantization enabling a roughly 3x reduction and distillation through active fine-tuning, reducing those costs even further. So we can deploy with an 8 billion size model. Red Hat is proud to not only be a leading commercial contributor to vLLM, enhancing the baseline performance of models, but additionally the core contributors to LLM Compressor and StructLab, enabling the previously mentioned compression techniques from quantization to data distillation. Not only that, but we have an extensive pre-compressed model selection available on our Hugging Face Hub. We've integrated these technologies across the Red Hat AI product suite, offering fully supported solutions for building, managing, and reducing your costs for AI applications, both on-premise and across cloud environments. With Red Hat AI, Teams can self-host their models on vLLM, controlling anything from data privacy and scaling on demand, all while utilizing the extensive product suites to compress and optimize their model deployments, while fully controlling the model lifecycle, evaluations, and data flows. Whether you're deploying RAG, summarization, chatbots, or any other AI-driven applications, make sure you compress your models, and you can do that using Red Hat AI's compression and fine-tuning technologies, and deploy them in vLLM for the best possible performance and cost savings. Ready to dive deeper? Check out the LLM Compressor, InstructLab, Compress Models, and vLLM docs, and become part of the community shaping the future of AI inference. Thanks for watching. We can't wait to see the amazing things you'll build with vLLM and compressed models.